the previous video, we derived the equations for time of flight, maximum height, and horizontal range. Now, let's find out the equation of the path which a particle follows when projected at a certain angle to the horizontal. Consider a situation where a particle is thrown with a velocity u at an angle theta to the horizontal. Let's consider the horizontal direction is x, this is the ground, and vertical direction as y. The particle will follow this path, and let's say it is thrown from origin. The point of projection, let's say, is considered as origin, and after any time t, suppose particle attains a height y and it covers a horizontal distance x. So the coordinates of this particle along this path, let's say, are x comma y after any time t. As we already know that the motion of particle along vertical direction is uniformly accelerated motion, and the motion of particle along horizontal direction is uniform motion. So we can use the equations of these two motions to find out the equation of trajectory. In equation of trajectory, basically we are aiming to find out a relation, an equation between x and y. Let's first talk about horizontal direction. Along horizontal direction, the distance covered x can be written as ux into t. And along vertical direction, since the particle is performing uniformly accelerated motion, the height attained y can be written as uyt minus half g t square. Let's say this is equation 1 and this one is equation 2. Here, if we substitute the value of t as x upon ux from equation 1 in equation 2, then we will get y is equals to uy, which is the component of velocity along vertical direction and can be written as u sine theta, into t can be written as x upon ux, which is u cos theta, minus half into g into t square, where t can be written as x upon u cos theta. So you get minus half g x upon u cos theta whole square. If you solve this equation further, you can cancel out u and u, and then you get y is equals to x into sine theta by cos theta can be written as tan theta, minus x square into g divided by 2 times u square cos square theta. If we multiply and divide by sine theta, in the second term, and slightly on rearranging these terms, y is equals to x tan theta minus x square divided by 2 into u square into this cos square theta can be written as cos theta into cos theta, and hence one cos theta I am going to take along with u square, while the other I'll take separately. And in place of this one cos theta, I am introducing the sine theta in denominator over here along with u square. Let the sine theta in numerator be as it is, and also you can take this g in the denominator over here. Now tell me what this term is. 2u square cos theta into sine theta by g. This is nothing but the horizontal range. So y is equals to x tan theta minus x square into sine theta by cos theta can again be written as tan theta divided by r. From these two terms, if we take x tan theta common, we will get y is equals to x tan theta into 1 minus x by r, which is the equation of trajectory. Here you can clearly see in this second last step that y is proportional to the highest power of x as 2. y is proportional to x square. What kind of graph do you get in such a case? If y is proportional to x square, it implies that this equation is a quadratic equation. And whenever graphically a quadratic equation is plotted, it gives you a parabola. And hence, the path followed by this object, which is projected at a certain angle to the horizontal, is parabolic in nature. It's a parabolic path. So that's all about equation of trajectory. Now, in the next video, we'll be talking about how does the velocity change with time in a projectile motion, and also how can you write down the velocity at any given instant. Till then, stay tuned with Tutorac.